Hi guys, you are welcome to Halogenius Ideas. In this tutorial, we are going to be talking about numbers in Python, how to work with numbers basically. So in Python, number data types represent numeric values and are classified into three main categories. We have the integers, we have the floating point numbers, and we have the complex numbers. Okay, most people don't use the complex numbers, but I'll make reference to it in this particular tutorial. So the first one, integers. Integers are whole numbers without any form of decimal point. Okay, so they can be positive, negative, or zero. And examples of examples of integers include, say, x equal to 5. You can also say y equal to negative 10. You can also do something like z equal to 0. These are very valid. These are valid Python integers. You can come here and say print x, come here, print y, then also come here to print z. No, z. So if I should run my code, you see I'm getting 5 minus 10 and 0, which is exactly what the values are over here. So the second one we are going to be talking about, the floating point numbers, which we refer to as floats. Okay, the constructor for this one is the int constructor. For example, if I want to come and look for the type, I can say print the type of, say, x. If I should run it, you see it is giving me class int, which is the constructor for integers. So apart from that, the next numbers that we're going to be talking about are the floating point numbers, which we refer to most times as floats. All right, floats. So examples of float is pi, for example, which is 3.142. Example of a float is I think sine 30, which is 0.5. Then we also have cos 30, which is 0.866, I think. So any number at all that has a decimal point in it, we refer to it as a floating point number. If it has a decimal point in it, in Python it will be referred to as a float. So another type of float, another way to represent a float is to use the e notation. In mathematics, there is this thing we refer to as standard form. Okay, where you have something times 10 raised to power of another number. So a way to write 2.5, you can do something like this: value equal to 2.5. You can say no, you can say then 3. Okay, so this is basically 2.5 times 10 to the power of 3. In mathematics, you'll be having something like 2.5 times 10 raised to the power of 3. Okay, so if I should print this value now, print value, and I run my code, guess what? It's going to be giving me 2500. Okay, which is 2.5 times 10 raised to the power of 3 basically. Let me clear my terminal. So those are floats. Then we have the last one, which we refer to as complex numbers, but most people don't actually use it. But I'll just show you that it exists. So for the complex numbers, you can have something like this. You can say complex numbers have a real part and the imaginary part, the same way we do it in mathematics. But please don't be intimidated by it. No, I've never come across a programmer that uses complex numbers. I know they exist, but personally, I've not encountered anyone. So complex numbers have a real part and the imaginary part represented as a plus bj. Okay, so the imaginary part is denoted using the j. Okay, so you can have something like c num, let me say num1 equal to, you can say 2 plus say 3j, and that is your complex number. I violated a variable rule here. So you might want to create another number. You have c num 2 equal to, let's say, negative 1 minus 0.5g. Both of them are valid complex numbers. Okay, they are valid complex data types. I should print c underscore num1. If I should print it, you see what it's giving me. You see what it's giving me. If I should print the type, if I should print the type, I'm missing something. Okay. If I should print the type, you see what I'm getting, class complex. So, but nobody uses it. Trust me. Just take your eyes off it for now. But if you have use for it, you can just learn it further. So, common operations and features of numbers. The first one that we are going to be talking about, arithmetic operations. Okay, arithmetic operations. You can be having something like this: arithmetic operations. You can be having something like this. You can have something like a equal to 5 and say b equal to 7, and you print, or you can even say sum equal to a plus b. Okay, you can say difference equal to let me say the absolute value of a minus b. Okay, you know that a minus b in this case will be giving me a negative number, so I can use the absolute value to find the absolute value. Basically, this is absolute value is something in maths. If you have the absolute value of negative 7, it will give you 7. The absolute value of 7 will still give you 7. All right, so I can just come here to print the sum and also the difference. Okay, so the print statement can print multiple things inside at once. So you can see the sum is what, 12, and the difference is supposed to be negative 2, but the absolute value is giving me 2. All right, so those are, that is it. You can also, all the arithmetic operators that we have, if you remember the arithmetic operators that I spoke about the I spoke about, let's just do a bit of recap: the addition, the subtraction, the multiplication. I spoke about the exponent, the normal division, the floor division. Then we also have the modular division. We have, okay, I think that is all. The other one is just parentheses, which you use to modify the order of execution. So yeah, all these operators, you can use them on Python numbers. So we also have the type conversion. You can convert between different numeric data types using the type conversion functions, which is their constructor, like the int and the float, for example. Okay, so you can have something like this. If I want to convert from int to float, an example of an integer might be something like 5. An example of a float will be something like 5.0. Okay, both of them are not the same thing. This is an integer and this is a float. For one reason or the other, I might have to convert from an integer to a float. That is where these type conversions, that is where they come into play. Okay, type conversion. So the type conversion, if I want to say I to float, I can do something like equal to, let me say float, then I'm passing in an integer, say 5. Okay, if I should come here to print I underscore f, okay, and I run it, you see it is giving me 5.0 and not 5. And initially the value, which is 5, is an integer, but if I should look for the type of I to f, if I should run this, you see it is giving me class float. Let me clear my terminal. It is giving me type float. All right, I can also do int. Then instead of 5, I can say 5.7. It will truncate the decimal part. It will truncate the decimal part. So if I should, let me print, actually this should be f to I, so that will be float to integer. So just to keep it consistent, float to integer. So this is also supposed to be float. Okay, so run this. So you see that it is giving me only 5. It will truncate the decimal part. It will take away the decimal part. Or let me use it this way. It will round it down to the nearest whole number. If you are having 5.9, it will round it down. All right. So that is how to do your type conversion. Another thing that you can do is if you have a string, if you have a string like this, okay, so normally this is 5 and this 5 is a string, okay. If you remember your string very well, this is a string. If I should run this, guess what, it is giving me 5. Using the int constructor, I can, if the string is a valid integer, okay, like the characters that make up the string are characters that will make up a valid integer, so guess what, I can use my int constructor to convert the string to, this is supposed to be d d, so this is supposed to be string to integer, okay. So this is a valid string. If I have 7 over here and I run it, you see that I'm getting 7 and I'm also getting class int, okay, and I'm bringing it from a string to an integer. And everything I do here I can do for the float too. I can say 7.3, then let me say string to float, float and float. If I should run this, guess what, I'm having an, oh sorry, this should be float, sorry about that. So run this, okay, you see, let me clear my terminal, so I can run this again. So you can see 7.3 and it's giving me a float. You can see that I tried using an integer the other time. It won't work because this is not a set of characters that make up an integer. So it will give me errors. I can only convert it to a float. So that is that about type conversion. You can also convert to complex. For example, I can have something like let me say value equal to complex maybe 2, then control D value. So if I should run this, guess what, it is now giving me the real part and the imaginary part, which is 0j, okay, but this is complex data type, so the type conversion, it works just fine. So we also have the mathematical functions. You can perform so many mathematical functions on your number data types, which is the integers, the floats, and the complex, using inbuilt functions in Python. So we have the math module. Okay, I'll do a video explaining the math module in more detail. But for now, I'm going to be showing you some few functions in the math module. So let me come here, the math module. So for this math module, for you to use it, the first thing you want to do is to import math. Okay, so I'll, in subsequent videos I will explain this better, but what is happening here basically is that there are some files that have been written somewhere inside Python. Okay, I'm trying to call those files and make them available so that I can call functions and classes from that particular file. That is what I'm doing here. So I can do something like result equal to math dots. Now you can see all these functions over here: arccos, arccosh, arcsine, and all these other ones. This is absolute value. I think the absolute value that we did the other time, ABS. If you want to use the math module on, this is it. You have factorial, you have floor if you want to round down. So we have gamma, a lot of things that you can do. We have so many functions, POW. So many things, but let's just take a couple of them. So the first one I want to take is the sqrt, which is used to find the square root of a number. Pass 9 in and let me print my results. You see, if I should run it now, you see I'm getting 3.0, okay, and you can see I'm passing in an integer. If I also pass in 9.0, it will also give me 3.0, okay. If I should do something like 9.1 and I run it, you see it is giving, let me clear my terminal. So if I should run 9.1 for example, it is giving me this very long number, but there is a way I can round this number down to whatsoever I want. For example, instead of printing result directly, I can also come here to do something like result equal to result, then equal to round. So the number that I want to round is result, then I want to round it to how many decimal places, let me say 4. Okay, now take note of how many figures I have over here. If I should run it, You see, it is cutting everything down to four decimal places for me. So that is it basically. This is one other function that you can use, but it is not in the math module, please. So you can just call around directly. So another function that we might use is the POW. It takes two numbers. So if you want to do something like x raised to power y, you are going to be passing in your x first, then after the x, you pass in your y. So let me come here and define my x and y. If I don't define my x and y and I run this, it will give me what we call the name error. Do I have x and y somewhere? Okay, I didn't know. My x and y are defined over here, and it is giving me this will be 5 raised to power negative 10. 5 raised to power negative 10, but I have no intentions of using this one. I actually want us to see the error. If I run this, you see I'm getting a name error. Okay, I'm getting a name error. We have so many type of errors in Python. All of them will be discussed in details. Just follow along. So result equal to math.pow. So I can say my x should be equal to maybe 10, and my y can be something like 3. So this will be 10 raised to the power, this should be y. So this will be 10 raised to the power of 3. Let me clear my terminal. Let me clear my terminal. So if I should run this, you see I'm getting 1000. So that is math.pow. The last one that I'm going to be talking about is the factorial. Okay, the factorial. So if you want to find the factorial of a number, for example factorial of 5, I think it should be 1 times 2 times 3, that is 6, 6 times 4 is 24, times 5, okay, so that should be 120, times 6 should be 720. Exactly. So that is for factorial. You have so many other functions that you can use this to carry out, a lot of them. Just take a good look at all the functions that you have. So just come here, pick anyone that suits your use case and just run along with it. So let me factorial maybe 4. If I run this, you see it's working just fine. So the last thing that we're going to be talking about under numbers, we are going to be talking about precision. Okay, so we have floating point numbers. They have limited precision due to the way computers represent real numbers, which can lead to rounding errors in some calculations. Okay, so we also have some special values in Python. You will get in some scenarios where you actually have to use them. We have the infinity and we have the not a number. Okay, we have infinity and we also have not a number. So most people won't actually bother talking about these ones, but let's just take a brief look at it. So I can have something like infinity equal to maybe float, then inf. This is how you generate infinity. If you want to generate not a number, let's say not a number equal to, you can say float and nan. Okay, let's print the two of them, print infinity, and save it. So if I should run this, you see it is just giving me inf directly. Clear. Then the second one, not a number, not a number. If I should save and I run this, guess what? It's also giving me not a number. So these are some special values that you have. Understanding the characteristics and use cases of these numeric data types is very crucial for writing accurate and efficient Python code, alright? Especially in mathematical and scientific applications. Choose the appropriate data type based on the requirements of your program to ensure precision and efficiency in numeric computations. So integers and floats are two different data types. Just know what to use in what use case, and you'll be able to write more accurate code. So thank you very much for watching till the end. Don't forget to like the video and subscribe to the channel. If you have any questions, please feel free to drop it in the comments below. Okay, and we have a support community as well. If you wish to join, it's open. Thank you very much, I'll see you in the next tutorial. Bye for now.